Imagine floating in the absolute silence of space. There's no air, no sound, just you and the infinite dark void. It's a terrifying thought, right? But what if I told you it's a question scientists and dreamers have been asking for decades? Could humanity actually live in a vacuum? Today, we're diving deep into this fascinating and, frankly, mind-bending idea. What would it take to build a sanctuary where, by all definitions, nothing should exist? First, let's get the obvious out of the way. Stepping into a vacuum without protection is a very, very bad idea. You wouldn't explode like in some sci-fi movies, but the results are just as grim. The lack of external pressure would cause the fluids in your body or blood, the moisture in your lungs and on your tongue to boil at your body's normal temperature. This is a phenomenon called ebullition. You'd also lose consciousness in about 15 seconds due to a lack of oxygen. It's a rapid and fatal process. So, rule number 1, don't go outside without a suit. But what if we weren't talking about a person, but a whole habitat? A city in the void. This is where things get really interesting. We're not just talking about a bigger version of the International Space Station. We're talking about a self-sustaining ecosystem, a bubble of life in the middle of nothingness. The first and biggest hurdle is creating and maintaining a breathable atmosphere. We need a perfect mix of about 78% nitrogen, 21% oxygen, and a tiny bit of other gases. Where would we get it? One idea is to mine it. We could potentially extract water ice from asteroids or the polar regions of the moon. Through a process called electrolysis, we can split water into hydrogen and oxygen. The oxygen is for breathing, and the hydrogen is a powerful rocket fuel. Nitrogen is a bit trickier, but it's found in the form of ammonia ice on distant moons. And we'd have to become cosmic miners, harvesting the very air we breathe from the rocks floating around us. It's a huge undertaking, but it's theoretically possible. But holding on to that atmosphere is another monumental challenge. Our habitat would need to be perfectly sealed. The smallest leak, a tiny micrometeoroid puncture, could be catastrophic, venting our precious air into space. This means the structure of our home would have to be incredibly robust. Think of materials far beyond what we use today. Perhaps self-healing polymers that could automatically patch small holes, or super strong carbon composites that can withstand impacts. We'd also need airlock sophisticated systems that allow people and vehicles to enter and exit without losing the entire atmosphere. Every single seal, every window, every door would be a critical point of failure. Then there's the pressure. We need to maintain a constant internal pressure of about 14.7 pounds per square inch, the same as sea level on Earth. This creates an enormous outward force on the walls of our habitat. Imagine a large sphere, say a kilometer in diameter. The total force pushing outwards would be astronomical. The engineering required to contain that pressure is on a scale we've never attempted. We're talking about walls that are meters thick, made of advanced alloys and composites, all while trying to keep the weight manageable enough to be launched into space in the first time. Beyond air, we need to solve the problem of gravity. Long-term exposure to zero-G is terrible for the human body. Our bones lose density, our muscles atrophy, and even our cardiovascular system weakens. To live permanently in space, we need artificial gravity. The most plausible way to create this is through rotation. Think of a giant spinning wheel or cylinder. Like the classic Stanford torus design, the centrifugal force would push everything outwards, simulating gravity. The bigger the radius and the faster the spin, the stronger the simulated gravity. But this introduces its own set of problems. The Coriolis effect would make things feel strange. If you dropped an object, it wouldn't fall in a straight line. Pouring a drink could become a complex physics problem. People might experience motion sickness until they adapt. It would be a constant, subtle reminder that you're not on Earth. And what about food and water? We can't rely on resupply missions from Earth forever. It's not a true survival. We'd need a completely closed-loop life support system. This means recycling everything. Every drop of water, from urine to shower runoff, would need to be purified and reused. Every bit of human waste would be processed to extract nutrients to grow food. We'd essentially have to build a miniature version of Earth's ecosystem. This means hydroponics, aeroponics, and maybe even raising fish or insects for protein. We'd have to master a perfect ecological balance. If our algae farms fail, our oxygen supply could dwindle. If a plant disease takes hold, our food source could be wiped out. It's an incredibly delicate dance of biology and technology. Let's not forget about radiation. Without Earth's magnetic field and thick atmosphere to protect us, we'd be constantly bombarded by cosmic rays and solar flares. This radiation can damage our DNA, increasing the risk of cancer and other health problems. Our habitat would need heavy shielding. This could mean surrounding our living quarters with a thick layer of water, or even building our homes underground on the moon or Mars, using the rock itself as a shield. But in a free-floating vacuum habitat, we'd need to bring that shielding with us, adding immense weight and complexity to the structure. Then there's the psychological aspect. Humans as social creatures evolved to live on a planet with open skies, weather on a 24-hour day-night cycle. Living in a sealed can, no matter how large, could lead to a range of psychological issues. Claustrophobia, anxiety, depression. We'd need to design these habitats with human well-being in mind. Large open spaces, virtual windows showing real-time views of Earth or other celestial bodies, and carefully controlled lighting to simulate day and night. We'd need parks, recreational areas, and places for social gathering to maintain a healthy society. Community and purpose would be just as vital as air and water. So, could we live in a vacuum? The answer is a qualified yes. It's not a matter of a single breakthrough, but a convergence of hundreds of them. We'd need to become masters of material science, robotics, artificial intelligence, ecology, and human psychology. We'd have to build a machine that is also a living world. A perfect fusion of the artificial and the natural. It would be the most complex and ambitious engineering project in human history. But the real question is, why would we? It might be out of necessity if Earth becomes uninhabitable, or it might be out of our innate curiosity, our desire to explore and expand, to see what lies beyond the horizon. Building a home in the void would be the ultimate testament to human ingenuity and resilience. It would be our way of taking a small piece of Earth, a fragile bubble of life, and placing it among the stars. It's a daunting prospect, but it's also an incredibly inspiring one. The journey to making it a reality will push the boundaries of what we know and what we are capable of. Thank you so much for watching. What do you think is the biggest challenge to overcome? Let me know in the comments below. And if you enjoyed this journey into the future, don't forget to like, subscribe, and hit that bell so you don't miss our next exploration.